3 is on a shape called an ellipse, which we just drew on the board with our 2 markers and the string, right? The plural of this, you can say ellipses or you can say ellipses. I believe ellipses is the correct way, but you can call it ellipses. So an ellipse has 2 axes, so it has a vertical and a horizontal axis. One of them is going to be longer than the other. So the longer axis is called the major axis. So, yes, like Eric Major. So in this case, the major axis would be like right here. And then the minor axis would be the smaller axis. Okay, and then the axis passes through points, each of the focus points. Yes, Eric?
Can you use the Pythagorean theorem?
There's ways to use Pythagorean theorem, yes. So that whole distance is the major axis. And it goes through points called the focus points, foci or foci, if you want to say. I believe the correct is foci. And it also goes through the vertices. Okay, so there's going to be 4 important points along that. So the end points here are called the vertices. And then there's going to be points in between that are the focus points. Okay?
So the focus points are halfway between the vertices?
They're not halfway. Yeah, so we'll talk about how to find those. And then the endpoints of the axis, so of the minor axis, so these endpoints, those are called the co-vertices. And it just helps us basically sketch in that ellipse so we know how wide it is. Okay, and then the axes are perpendicular and they intersect at the center of the ellipse. So when I said it goes through 4 points, it actually kind of goes through 5 points, right? It goes through that center as well. So along the longer axis, you're going to have 5 points drawn in. Okay, so same thing for the vertical. So your major axis in this case would be here, right? And then the minor would be this other axis. Okay, so there's lots of charts that help you like memorize all this information about the ellipse and hyperbolas, which we'll get to eventually. I always say do not memorize this chart. So do you guys see this chart? That's a lot of things to memorize. And if you don't understand where it's coming from, you're not going to know how to do these problems. Okay, so really we're just going to talk about what a sketch looks like, how to sketch it out, and you guys are going to figure out what all these formulas are. Okay, so don't memorize the chart at all. Okay. And then it says for ellipses, c squared is equal to a squared minus b squared. That's what Eric was just asking. He was saying, does it use the Pythagorean theorem? And I was like, kind of. It's almost the Pythagorean theorem, right? It's minus. Okay, and the way that I'll have you guys remember that is that if you have a plus in your equation, it's a minus in this equation. So a hyperbola will have a minus in the original equation, and then it's going to be c squared equals a squared plus b squared. Okay, so that's the difference. All right, so we're just going to do some examples. I think you guys are going to figure it out. All right, so it says graph the ellipses, determine the center, vertices, co-vertices, and foci. Okay, so if I have x squared over 25 plus y squared over 16 equals 1, the form that's above looks like this. It says x minus h squared over a squared plus y minus k squared all over b squared equals 1. So we need to determine what h, k, a, and b are. Okay, so h and k are kind of like with the circle yesterday, right? Do you guys see what those are? Yeah, Christopher.
How do we know whether to use the horizontal or the vertical?
Don't worry about that right now, but basically for an ellipse, it's going to be the number that's underneath here. Do you see the 25 and the 16? If you take the square roots of those numbers, do you guys see the 25 and the 16? What's the square root of each of those? 5 and 4. Which one's bigger? 5. So if it's under the x value, then that means the bigger number under the x means it's wider. It opens up along the x-axis, so it's wider. But if it was bigger under the y value, then it's going to be taller. Okay. When we look at this, can we tell what h and k are? Just like the circle, yeah, it's 0. So our center is going to be 0, 0. Because it's like x squared, so there's no like x minus 1 squared or anything. So it's like x minus 0 squared. All right, and our a and our b, so for an ellipse, a is always bigger than b. But be careful, this is only for an ellipse. So hyperbola a can be either one. Kind of confusing. So a in this case is going to be 5 because it was the square root of the 25. So what's B? 4. Okay, so with this, we said we knew that it was a horizontal ellipse because it's bigger under the x value, okay? So what I do a lot of times when I'm teaching this is underneath the x, I'm like, okay, that number was 5. I'm moving right and left 5. And underneath the y, I had 16. So I'm like, okay, that's under the y, so that moves up and down. So x moves right and left, y moves up and down. Makes sense, right? It would do that. So from our center, so at 0, 0, we're going to go right and left 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And we're going to go up and down 4. Okay, so this one looks almost like a circle. It's just slightly compressed, right? So when we draw it in, we get this. All right, so which one's the minor axis? Which one's the major axis? Yeah, here. Yeah, so like the horizontal one is the major axis, the x one, and then the y is the minor, right? Do you guys see that? So when I talk about the vertices, I'm talking about these points on the right and the left. Those are our vertices. So that's a vertex and that's a vertex. Okay, so those points, it looks like they're 5, 0 and negative 5, 0, right? And then the co-vertices, those are these other ones. Yep, top and bottom. So those ones are going to be 0, 4 and 0, negative 4. So the last thing we need are those special points, those points that helped us draw out the ellipse, kind of like with a compass, but not a compass. It's like with that string. So we need to find those important points. So we find the foci by using, not the Pythagorean theorem, but really close, a squared minus b squared. Okay, and this is why a actually has to be bigger for an ellipse. Do you guys see if a wasn't bigger, then we're going to get c squared equals a negative number. Yeah. So if I plug in a, I'm going to get 25. So I have 25 minus b squared was 16. It was just our two denominators. Yeah, but it's a squared, right? So c squared equals 9, so c is equal to 3. And you could say plus or minus 3, but I just write 3. It's a distance, so 3 is fine. So from the center, I'm going to move to the right and left 3. So I'm going to go 1, 2, 3, 1, 2, 3, and that's going to create the focus points. So those are 3, 0, and 0, negative 3, 0. They're not on the minor axis. Yep, because remember how we just drew it? We just have those 2 points. Okay, do you guys see it? Okay, that one was kind of nice. There were lots of really nice numbers there. They're not always going to be nice. Sometimes c is going to be like the square root of 7, right? So sometimes it's a little gross. And this one was centered on the origin, right? At 0, 0. They're not always centered at the origin. So let's try some harder ones. So this next one says we have y minus 2 squared over 25 plus x plus 3 squared over 9 equals 1. So when I look at these numbers on the bottom, I know I'm going to have 5 and I'm going to have 3. Let's write where they're going. So the 5 is underneath the y value. So because it's underneath the y value, it's going up and down from the center. And the 3 is underneath an x value, so it goes right and left. Okay, that will help you determine which one's the major axis and minor axis.
What happens if you get the y value that's greater than the x value?
If the y value is bigger than the x value, then that just means that it's opening vertically. Like it's like a vertical ellipse. Does this make sense?
So would you still put it all down, or would you just put no solution?
What are you talking about? This is good. Yeah. I mean, they would just be switched around. Is that what you're saying?
No, I'm saying like if they have a y value bigger than an x value, would you write no solution, or would you still solve it?
No, it's okay.
I mean, just
Yeah.
It
Anna
just
Catherine.
makes a different shape.
Yeah.
So does the y become an a value?
So the one that's underneath the y is then a. Yep. Do you guys see that? So a has to be 5 and b has to be 3 for an ellipse because this is the big one. All right. How about the center? This is kind of a trick question. Almost. Everybody always does this on the test. You guys see it? She said 2, negative 3.
-2.
Yeah, you got to do the x and then the y first. So we're going to say -3, 2. So be careful. So x first. Do you guys see that? Okay, so we're going to start at -3, 2. And from that center, I'm going to go up and down 5 and right and left 3. So I'm going to go up 1, 2, 3, 4, 5. I'm going to go down 1, 2, 3, 4, 5. Right and left 3. And we create an ellipse shape. All right, so our vertices are the ones on the top and bottom, right? These are the vertices. So those points, think about it. If I went up and down 5 off of the center, look at the center, -3, 2. If I didn't have a picture, would you guys be able to figure that out? Because you go up and down 5 off of this. So which value is going to be affected, the -3 or the 2? The 2, right? You're going to go up 5 from it and down 5. So I'm going to have -3, 7, and I'm going to have -3, what? -3, -3, right? But luckily we have the picture, so we could also just count. So you could count those. So co-vertices, we're going to go right and left 3 off the center. So previously we had the -3, 2. If I go right 3, I'm going to be at 0, 2. And if I go left 3, I'm going to be at -6, 2. And you can check that's where these points are, so we're good. And then the last thing are finding the foci. So the foci, we're going to do our c² is equal to a² minus b². So we just take our two denominators and we subtract them. So again, I gave you a nice one. I try to give you nice ones. So we get 4. Sometimes. So I'm going to go up and down 4 off the center. So up 1, 2, 3, 4. Down 1, 2, 3, 4. So it's like that. So that's going to be the point -3, so off the center, if I go up 4, I'm going to have 6. And if I go down 4, I'm going to be at -2. Okay. Yeah, cool.
Is it that the closer those 2 points go to the center, the more it looks like a circle, and the farther, the more...
Totally. Do you guys see that? Can you kind of visualize that with our little activity we did? So he said the closer the points are, the C's are to the circle, does it look more like or to the center, does it look more like a circle? Yes, that's true. So the further apart, it's going to look more stretched out. Yeah.
Logistically speaking, it's possible to do this without actually having an ellipse.
What do you mean?
Like having one on the graph. You can do it mathematically.
Yeah, you can do it mathematically. So that's where all of the formulas come from. So when it talks about like a horizontal ellipse, that means you're moving right and left off the center. So if your center was h, k, do you see how it's writing h plus a, k, h minus a, k? That's where those formulas are coming from. So I wouldn't memorize these formulas. I would probably just know how to use the picture, right? All right, so it says write an equation of the ellipse in standard form with the following characteristics. And then I said a rough sketch always helps. So let's do kind of a little rough sketch here. So we have vertices at 1, 9. And at 1, -1. So if those are our vertices, it's going to be a vertical ellipse, right? And our co-vertices are at 3, 4. And -1, 4. So here's the ellipse that we have. Okay, so the distance between our two vertices is not A, that's actually double A, right? 2A. Do you guys see that? Because it's going from the center out. So if I'm going from a height of 9 and I'm going all the way down to -1, how many units would I have to go down? 10, right? So that means I have 5 here and 5 here. So my A value is 5. And if I go across from the co-vertices, they were at x equals -1 and x equals 3. So if I go from -1 to 3, how much do I go to the right? 4, right? So I'm going to have 2 and 2 exactly. So my b value is 2. All right, you could find c now, but we don't need it for our equation. The only other thing we need for our equation is our center. So our h and our k. Can you guys tell what the center is? How much do you go over to the right? 1. How much do you go up? 4, exactly.
From which point?
From this point here. Like to get from, I guess I was saying like from 0, I go over this much up that much.
Oh.
All right, now we set it up. Now for an ellipse, it doesn't really matter if you start with x or if you start with y. It's really just, it matters what number is underneath the x's and which one's under the y's. But a lot of times the textbooks will put, like if it's a vertical, they'll start with y. So we can do that. We can start with y. It doesn't matter though. I won't count you off on the test. So we're going to have something squared, and it's always going to equal 1. That's part of our equation. Just because you can divide out by something to make that a squared and b squared something else. It's just like the standard form. All right, so if we start with y, we're going to have y minus 4 because I want to use the y value from the center. And if I have x on the next one, it's going to be x minus 1. Yeah, and it's just textbooks will do that. You guys don't have to do that because notice how it's a plus anyway, guys. So if you have a plus, it doesn't matter which side it's on. For a hyperbola, it is going to matter because we're going to have a minus in between it. So like switching the order matters, right? We can't do that. All right, and so the A was how much we were going up and down, and the B was how much we were going right and left. So what am I going to put underneath the y minus 4 squared? 25, right? Yep, 5 squared. And then what am I going to put under the x minus 1 squared? 4. Yep, that's your standard equation. Does this make sense? All right, so same thing on this next one. So it says we have a covertex at 4, 0, and we have a focus at 0, 3. So will this one open vertically or horizontally? It's tricky because the focus is vertical, right? It's saying our center's here. So it's going to open like this. It has to go around that focus. So we don't have our A value, but we have this distance, which that becomes our C, right? So our C is 3. And we have this distance, which is our B value. So B is 4. It doesn't go all the way to the top. It just goes to the focus. I don't know. What do you guys think? How can we find what A is? Yeah, what do you think, Michael? A squared minus B squared. Yep, exactly. So we're going to have 3 squared equals A squared minus 4 squared. So we're going to have 9 equals A squared minus 16. We add the 16 over. So we get A equals 5. So since it's vertical, we'll start with our y. So we're going to set up with our something squared over equals 1, right? So I'm going to have y and x. And this one is luckily centered at the origin. So it's like minus 0, minus 0. We like that. So you could just write y squared and x squared. You don't have to do the minus. And underneath the y, that was our a value. That's going to be a squared was 25. And underneath the x, that's going to be our b value squared. So 4 squared is 16. You don't have to. So you could just do y squared over 25 plus x squared over 16 equals 1. So the 0, 0 comes from the center. So the center right here was centered on the origin at 0, 0. That's where that came from. All right, are these making sense? You guys like the ellipse equations? You know it's vertical because the focus, the foci are going to be, there's basically going to be 5 points along the major axis. So you're going to have the vertex, the focus, the center, the focus, the vertex. So if the focus was vertical from the center, then it has to be a vertical
Okay.
ellipse. You get it? All right. Same thing. Do you guys want to try them? Try to sketch them out. You just want to do? You want me to do it so you can get your homework? All right. So your center is at -4, 5. And now it says the length of the major axis is 18 and the length of the minor axis is 12, and it's a horizontal ellipse. So if it's horizontal, that means we're going to go out a distance of 9 horizontally, and we're going to go up and down a distance of 6. Do you guys see why we would do those numbers, 6 and 9? So this is 2a is equal to 18, so a is going to be 9. And this is 2a, or 2b equals 12. Do you guys get why it's 2b and 2a? Because when you have an ellipse, the distance to the from the center to the vertices, this distance is a and this distance is a. So the whole thing has to be 2a. So you could go in both directions, and you could have a total of 18 and a total of 12, right? Okay, so we have our A and our B. Do we have our H and K? Yeah, so we had -4, 5, right? That's our H and K. So since it's horizontal, I'm going to start with my X. So I'm going to have X minus a -4, so +4. And I'm going to have Y minus 5. And it's going to be over A squared and B squared. So a squared, that's going to be, we went right and left 9, right? So I'm going to have that under the x. So it's going to be 9 squared is 81. And then 6 squared is 36. And that's our answer. All right. This one's saying we have the focus at -3, 4. And then the other focus is way up there. I should have drawn this better. At -3, 10. So if I go from 4 to 10, how many units long is this? 6 units long, right? So where's my center? It's in the middle. What point's going to be in the middle? -3, what? Yep, exactly. So my center is going to be at -3, 7. Do you see how we get that? Because the distance between 10 and 4 is 6. So if we go from 4 and we just go up 3, then we're going to get to the center. Or if you start at 10 and you go down 3. So we have the center. So now we have to find, so we have C. Do you guys know what C is? C is the distance from the center to the focus. So it's 3. And we have A. A was given to us. A is 5. So because of that, we can find B. So we're going to do our C squared equals A squared minus B squared. So I'm going to get 9 equals 25 minus B squared. I wasn't very original. I made like 16 on all of these. All right, so B is going to be 4. And it's going to be, is it going to be vertical or horizontal? What are your thoughts? Yeah, what do you think? It's the distance that you went from here to here, to the center to the focus. Yeah. How did I get the 7? The center. Well, I got the center because I knew that if I was going from a distance of 10, well, like from 4 to 10, I go up 6 units. And that's going to separate your 2 focus points. And remember, like, it's always going to be like you have your vertex, your focus, the center, the focus, this vertex. So this is our C. So this together makes 2C, and it was a total of 6. So it had to be 3 and 3. So then from that center, you go up 3. Does this make sense, guys? You get it? Okay. So we have that. And then, so it's a vertical, so we're going to start with Y. So we're going to have Y minus 7 squared plus X minus a -3, so plus 3 squared. It's all going to equal 1. And we're going to divide by our a, which was 5 squared, so 25, and our b squared, which is 16. So that's our equation. Okay, is this making sense? Do you guys get it? You can skip the last one if you want. It's kind of interesting. But... All right, so we'll stop since it's an E day.